Hello everyone. So the objective of our project is to predict gas price, and the dataset that we are going to use has been created from various sources of this particular website, ei.gov. So first we acquired a raw dataset over here, and our first task is to clean it. So by clean, we're going to fill these missing values and do various other pre-processing as needed. And to help us with the cleaning, we are going to take help from these two packages, QC and DP over here, that were created by us. So QC will let us know about the quality of the data, quality check, which is QC in short. So QC will help us to check the quality of the data. It helps to describe the data set to us, and this DP class, which performs data processing. So all the necessary data processing will be performed by this DP class. So these two classes have been used for cleaning, and at the same time we also specify our target variable, the one that we are going to predict. In our case, this is the gasoline price, and which is this one, New York Harbor, this column. So this is our target variable, and this is what we are going to predict in this project using different machine learning techniques. So basically we are going to use 4 regressors, about which we are going to talk further. So here is the data cleaning step. So as mentioned earlier, in data cleaning we first specify the target variable and then fill all the missing values with their respective medians. So in this case, this column had these missing values, so they have been filled with the median of this particular column, and similarly all the other columns will be filled with their respective medians. So after the data has been cleaned, it is stored so that this particular clean data can be used for the further step. After cleaning, we do a quality check just to make sure that all of our variables are in the way that we need. So from this quality check we can see that none of these predictors have any missing values, so we're good to go. So first we are going to perform some exploratory data analysis, and the very first task is to check the trend of our target variable. So our dataset is from June 1986 all the way to August 2022. So this is a line plot which shows how the price has changed over time, and here we have a correlationship analysis for each and every predictor with our target variable. So the first one, the first scatter plot over here, shows relation of the first predictor with our target variable, and similarly we have all of the 7 predictors over here, and we can see that the first 2 predictors have a strong positive correlation with our target variable. And then we check the correlation matrix over here. This matrix helps us find correlation between different predictors. So as you can see over here, based on that correlation matrix, which suggested a strong correlation between Cushing OK WTI crude oil spot price and Europe Brent spot price, so we have plotted that correlation over here, correlation trend for crude oil price. So here is this first graph, and similarly we have plotted the percentage of stock held in SPR over here. So these 2 predictors also showed strong correlation among them, and after correlation analysis we are ready for modeling. So first job is to take our cleaned data and make it model ready, and by model ready we are basically going to remove outliers from each and every predictors. Outliers are going to mess up our prediction, so better have them removed, and in this step we have removed the outliers. And after we have removed the outliers, we are going to split our data set into 80-20 ratio, where 80% goes for training set and 20% goes for test set, and this split is completely random. And after we have splitted the data set, we have decided to transform our predictors. So we have done min-max scalar to normalize them to make all the predictors scale invariant. We are going to find out whether this had any effect on our prediction. The first regression technique that we are going to use is linear regression, and over here we have fed the model with normalized data as well as untransformed data just to see the difference in performance. So as you can clearly see over here that the coefficients that are given to us in case of untransformed data are significantly different from those that belong to normalized data. Let's see what else we have. On analyzing our predictions, we can see that there is not much difference between transformed data and untransformed data. So we have fairly similar mean squared error, and we have almost similar test R squared and test adjusted R squared value. We might conclude that Maybe it might be because of the dataset, or probably feature scaling did not have much effect on predictions rather than feature importance. Let's see what our other models have to tell us about that. And before moving on to other models, we have these visualizations where the blue lines, they represent the actual gas price compared to the predicted gas price of our model, and our first plot is without any normalization and second plot is with normalization. So we can see that it's almost similar. Both of them are almost similar to each other. These are the observations that we have seen. And moving on to decision tree regressor now. So this is our second regressor, and here are some parameters on which we are going to perform grid search so that we can have best parameters based on some score. This score is not R2 or adjusted R2 though. So after having grid search, we have even checked its performance with a decision tree where we entered manual parameters. So these parameters are completely manual and random. So we have seen significant difference, as can be seen in mean squared error. So in case of grid search, we have a very low training MSE compared to test MSE, but in case of our manual decision tree, we have not very low training error. But the main interesting thing is the difference between training and testing MSE. So in case of grid search, there is a possibility of overfit, but in case of our manually created decision tree, it does not imply too much overfit. So if we had a large data set, maybe we could have found it out, or we can find out with some different test data set. And after MSE, we have the comparison of R squared and adjusted R squares, as can be seen over here. So over here, there is a plot for our yellow line depicting actual prices. The red dotted line, it depicts the decision tree prediction that had parameters from grid search, and after that we have this blue dot and dash lines that show the predictions from our manually created decision tree. So we can see that the blue line performs much better. If anyone is interested in finding out the underlying working of the decision tree, here is how it works. So it's quite blurry, but anyways, all the images are saved in our results folder. So moving on, and we even checked the difference between predicted values of normalized data and untransformed data, and again we have seen exactly similar output. So it's like there is a total overlap. Up next we have random forest. So this is the third regressor that we are going to use, and over here also we have done a grid search. These are the parameters, and we have checked our training and test MSE, checked our R squared, adjusted R squared, and then here we have our plot. The blue line depicts actual price and red dot and dashed line represents predicted values. It performs really well though. And in the end, we have our final regressor model, XGBoost, and we have done similar grid search over here. Due to limited resources, we did not set a too large of a parameter grid. We had a few parameters over here, but there is still a scope of using a really large parameter grid, and like we can find out parameters that might have been proven to be even better than the one that we have over here. But even though with all those parameters, these are the predictions that we have. Again, blue line depicting actual values and red line depicting predicted values. We can see this is performing slightly better than our random forest in some areas. And again, if we want to check our visualizations, we have all of them saved in the results folder. And here we have some future scopes for development, as we have mentioned earlier, that we can perform correlation analysis over here. Like we can check how the correlated variables affect our prediction and so on. And in case of decision tree, we can check out feature importance, and then we can retrain the decision tree based on those important features. For random forest, we can check the performance of our grid search parameter random forest with some more manually searched parameters. And for XGBoost, as we mentioned earlier, we could check for an even larger parameter grid. That was all for our project. Thank you.